Hi everyone, welcome back. I'm Miss Lin. It's great to have you here today. Today we are going to look at merging. And first, we will go through the key concepts, and then we will do some questions together just so that you can see how to apply the knowledge. In the end, I'll include some questions for you to have a go at. Let's first look at two sets of data. Let's call it set A and set B. Merging is when I combine two sets of data and I want to work out the total mean and the total variance. In order to work out the total mean, we have to work out the total sum of x divided the total number of n. You may be thinking, well, this is so easy, I can just add these two sets of data together. But in some cases, we are not given all data and we are only given some information about the data. Therefore, we won't be able to work out the total sum of x straight away. So let's use this simple example to get the idea of how to work out the total sum of x. For the first set of data, we know that the sum of x is going to be 15. For the second set of data, the sum of x is 40. So let's look at sum of x in total. You can double check. If you add 1 to 10 altogether, you get a total of 50. Therefore, in order to work out the total sum of x, you can simply add sum of x of the first set of data and the sum of x of the second set of data. To work out the total variance, we know we are given the formula. It needs to be sum of x squared take away n times mean squared over n take away 1. So that means we have to have sum of x squared as well. So let's just double check. Does that work in the same way as sum of x? So sum of x squared of the first set of data is 55. So that means I do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Sum of x squared of the second set of data, 330. So if I wanted to work out sum of x squared in total, if I add sum of x squared of the first set of data and sum of x squared of the second set of data, I have a total of 385. You can try this out and then you will get the same answer. These two are very important. So let's look at an example and see how we use this to combine data. We did this question in a lesson. This time we're not given the exact data, but we are given the information about the data. So with Emily's data, mean is 2.5, variance is 2.7, and the number n is 20 because Emily asked 20 people. With Sarah's data, n is 25. Now what we need to do is we need to combine these two sets of data and find the total mean and total variance. The total mean does not equal to the first mean add the second mean divided by 2 because n is different in two sets of data. So what we need to do is we know the total mean equals to the total sum of x over the total n. We now know the total n is 20 plus 25. How would I work out the total sum of x? But we know the total sum of x is the same as the sum of the first set of data add the sum of x in the second set of data because you know sum of x divided by n equals to the mean. In this case, sum of x divided by 20 equals to 2.5. So this tells us sum of x in this case is 50. Similarly, for the second set of data, we needed to do the same. Sum of x equals to the mean, which is 3.4 times by 25, and that gives us 85. Therefore, the total mean is going to be 50 add 85 all over 45, and therefore the total mean is 3. We now can use a similar method to work out the total variance. The formula is sum of x squared, that needs to be the total sum of x squared, take away n, that needs to be the total number of n, times by the total mean squared all over total n subtract 1. We have just worked out the total mean. We now know the total n. Therefore, the only thing we need to find out is the total sum of x squared. But we also know total sum of x squared equals to sum of x squared of the first set of data add sum of x squared of the second set of data. With the first set of data, we are told variance equals to 2.7. Variance is sum of x squared take away n mean squared over n subtract 1. Therefore, 2.7 equals to sum of x squared, which is something we want to find. Subtract 20 times the mean squared, which is 2.5 squared, and that's over 19. To work out sum of x squared, what I need to do is rearrange and solve for sum of x squared, and that gives us 176.3. Similarly, we can use the same method to work out sum of x squared for the second set of data. The variance is 4.2 equals to sum of x squared take away n is 25 times 3.4 squared over 25 subtract 1, which is 24. Therefore, sum of x squared for the second set of data is 389.8. We now have everything we needed to work out the answer. So total variance equals to 176.3. Add 389.8. Subtract total n, which is 45 times by the total mean, that was 3, and that's over n subtract 1 is 44. Put that in the calculator and that will give us the answer, is 3.66 to 2 decimal places. So now what I would like you to do is to try this homework question again and see if you are able to work out the final answer. Remember, maths isn't a spectator sport. You can't get better at maths if you are only watching other people doing it. Well done for making it through to the end, especially if you have done the questions yourself. Happy learning, and I'll see you in the next video. Bye bye.